And David, do you have contact for Bill?
I checked and I could not find a phone number, unfortunately.
Okay. So, yeah, I guess let's go ahead and start then. So, Jiasheng and Wolfgang, if you want to kick it off.
Yes, sure. I would like to kick off our panel. So our panel is 20 years of visual antics. I'm a mediator, Jiechong Zhao, assistant professor at August University.
Yeah, I'm the other moderator. My name is Wolfgang Jettner. I'm a research scientist at the Data Institute for Societal Challenges at the University of Oklahoma.
So first, I would like to have some review of our 20 years history. So in with the funding of the National Visual Antiques Center at PNL in 24, and then later we get have the publication of illuminating the past in 2005. Then all this with this all the funding comes in. Later, we have this symposium of visual antique science and technology, which we just abbreviated for VAST. And also, we have this VAST challenges to bring all this complicated data and big data and these tasks to draw a lot of attention of the academic and also companies to solve complex data visual antiques problems. And later in 2008, we have this Visual Master Initiative in European Union, and also later it published the Visual Antiques Roadmap in 2010. And in 2009, we have the VAST as a track at the IEEE this week. And then we also have the funding of the Visual Antiques Vaccine Center at DHS. With all this sort of funding comes in and our research, growing our researches, we had another very promising 10 years with all this growing of the visual antiques technologies. Now in this panel, we're gonna have a reflection of what we haven't in the the previous 20 years, and to have a more interesting perspective and challenges what we can do in the next decade. Yeah, we're gonna have two great panelists in our panel, and we will have Wolfgang introduce them.
Yeah, so as of now, we have 3 of the panelists here. Amazing to have you here, guys. We start off with Daniel Keim. He's the head of the Data Analysis and Visualization Group at the University of Constance in Germany. He won the VGTC Technical Achievement Award in 2011 for high-dimensional data analysis and visualization of large databases. He was the scientific coordinator of the EC-funded coordination action Visual Analytics Mastering the Information Age, also called VisMaster. Next, we have Sylvia. She is the visual analytics researcher at the Vienna University of Technology in Austria. She also received a VGTC Technical Achievement Award in 2023 for outstanding technical contributions to visual analytics of time-varying data. And she founded the center of the Laura Bassi Center of Expertise, CVAST Center for Visual Analytics and Science and Technology. Then next, Bill. He's still missing, but he might join us later. Bill Pike, you already know him from our keynote. He's the Chief Science and Technology Officer of the Pacific Northwest National Laboratory in the US. He previously led the PNNL's Visual Analytics Research Group and served as research coordinator for the National Visualization and Analytics Center. He established long-term research and development strategy connection advanced computing to applied science and engineering domains. And he's also one of the founding members of the VAST conference. Our last panelist is David Ebert. He's the director of the Data Institute for Societal Challenges. He's also the director of the Visual Analytics for Command and Control and Interoperability Environments, that's the Vaccine Center at DHS. He's also an associate vice president and research of the Gallopy Chair Professor and of the ECE and Computer Science Department at the University of Oklahoma. He also won an VGTC Technical Achievement Award in 2016 for foundational work in visual analytics and he's one of the authors of Illuminating the Path.
Okay, now let's start with our first questions. So this then I will just turn off this screen sharing. So the first question is, has visual analytics achieved the impact it had set out to achieve?
So I can go ahead and start answering that, and we'll go around to the panel. I think it definitely has. When the field first started, there was a small group that were really focused on creating interactive visual environments for analysis, decision-making, and understanding things. And now it's pretty much ubiquitous within our field and in the way science and discovery is being done today. So as Bill mentioned in his keynote, one of the signs that it's been so successful is the fact that people don't think of it as something separate anymore. It's just part of the whole process of discovery and innovation and decision-making today.
I personally find it very fascinating that now when I go out, everybody knows the term visual analytics. If you go to a company, they know what visual analytics is. They talk to you about it. So it's like 20 years ago, you had to explain what visual analytics is. So what do we actually want to do here? And now basically people know. Maybe they don't have the same understanding as we have as researchers. Sometimes they have more applied understanding, but it's omnipresent, it's everywhere. So I think that is a success, clear success. And of course, companies like Tableau are known, they're established, and everybody knows them. And they have also the label visual analytics on their front.
And I also think it was a great success. At the beginning, we really had to explain what is visual analytics, where is the V for, where is the A for, and nowadays also in the scientific community, everybody is doing visual analytics. Yeah, they don't call it visual analytics, but it's in their heads. And I think this is a big success that you don't have to name it anymore, but the people are doing it. If you look at the conference, what is presenting there, everything is nearly visual analytics. They call it sometimes SciVis, they call it sometimes InfoVis, but it's visual analytics. This is a big success. We don't have to name it. And it's much easier to pronounce than visual data analysis for a non-native speaker.
Yeah. So since we all agree, let me caution that if we look at the agenda that we put forth like 20 years ago, we haven't achieved everything that we wanted to achieve. So like it's a big success, but we are not there yet. The science of analytical reasoning, I'm not sure. The integration of cognitive science, I'm not sure. There are many things that we haven't fully achieved that we set out for. So let me caution ourselves a bit. It's a success, I fully agree, but we are not done. And the other problem is, of course, now AI comes in, so things have changed. Some of the problems that we were trying to solve with visual analytics are now solved by AI alone, or almost solved, or parts of it are solved. So yeah, there's still plenty of work and new things to do that we haven't had on the agenda 20 years ago.
And I would echo the integration of people from the cognitive science domain and visual cognition in different areas is an area that has been lacking, as well as the whole community of decision science. A number of us made a lot of outreach efforts, attended, the Association of Psychological Sciences conference, did workshops, and we probably weren't good at communicating to a new domain and presenting what we were trying to do in terminology that they understood, that we didn't get a strong buy-in. But people like Brian Fisher, Barbara Tversky were very good at helping with outreach there. But there's so much more to be done. And especially as we're talking about now large models and even greater size of terabytes, when people are talking about 2 terabytes per second coming in from sensor systems, sort of the whole idea of what human reasoning capabilities are and how to really leverage the automated and AI analytics with the human knowledge are areas that still that outreach and understanding to neuroscience, cognitive science, and decision sciences is needed in our field.
So you were talking about cognitive sciences. What about the big machine learning conferences? Do you think visual analytics has gotten a hold there?
I mean, if you think about how we define visual analytics, yeah? We defined visual analytics is the intertwinedness of visualization and automated analysis methods. Yeah? And the automatic methods start with simple statistics and go to data mining and machine learning and AI. Yeah? Therefore, we already integrated everything here, that we really wanted to intertwine visualization and this analytical method, and one part of is machine learning and AI. And for example, if you look at different kind of conferences, they are just mentioning visual analytics for machine learning or AI machine learning for visual analytics or this. What does this make sense? It's already in the name. Yeah? We don't have to reinvent the wheel. We already defined it 20 years ago. Therefore, I'm always curious if I see a session called AI machine learning for this or the other way around. Huh?
I fully agree, but what I don't see happening is that any of us can deal with all the papers that come out in NIPS and all the machine learning conference, ICLR, and so on. There's plenty of like 10,000 papers a year at least that is coming out there, and I at least can't be on top of that. There's no way, even with my whole group, to catch up on all that is going on there and really integrate it with our work. So there is really a big task in front of us that I don't know how we want to handle it. Like our conference is small, really small. Yeah.
Just to tell you, just to give you a story. Yeah, I give you a story. We are always wanted to solve real world problems. Yeah? And we want to solve real world problems. We're collaborating with domain experts. Yeah? This could be also applied for the experts in machine learning and AI. Yeah? Because it's part of computer science, we are not experts. We have to team up. Yeah? And I think this is would be our next steps, to team up. Yeah? I just organized the Dachstuhl seminar about process mining and visual analytics. Yeah? I didn't have any clue about process mining, but it's also a form of machine learning. Yeah? And you have to learn these algorithms and you have to team up. For me, the keystone is currently that we team up and see the machine learning AI person as the same citizen. And not being ignorant, it's computer science, therefore we can handle it.
So two comments that made me think of. First of all, last week with the Nobel Prizes, both the physics Nobel Prize and the chemistry involved machine learning, right? And we had computer scientists who received, people who had gotten the Turing Award got a Nobel Prize for the first time, which I never thought would be possible in my life. Yep. And with the use of integrated visualization, the question becomes, how many of those people could, how many of these discoveries could not be, have been achieved without the use of visualization in part of the process? And maybe that will be coming in the future. But it shows that machine learning people have been focusing a lot on domain science, and they're actively integrated in pretty much anyone you go to hire now, whether you're talking medical research, omics research, genomics, or a lot of different areas. They need to know machine learning. Question is, do all our tools become as integrated as these tools in the discovery process? I think they already are having some effect. They haven't shown the value that machine learning has yet. And I think that when I look at the explainable AI workshop at the Viz conference, I see it as one of the examples of how visualization and visual analytics especially comes into play in helping understand everything that's going on in the field of AI. And it's really important for humans to trust and understand what's going on in AI.
Yeah, but they need us as visualization experts, yeah? Because if you look at their visualizations, also the Nobel Prize winners, yeah? If you look at their visualizations, yeah? I don't ask for new visual metaphors, but I ask for simple, intuitive, good visualizations, yeah? And we all know we can apply machine learning for well-defined problems. If we don't have well-defined problems, we need, first of all, visualization to grasp what's going on. Yeah? And the machine learning algorithms are good for well-defined problems.
Yeah,
It's the
we
same
have.
with statistics.
Sorry for the interruption. We have a question from the Discord. So is that they are trying to ask, do users and domain experts still need us if visual analytics is known and done by everyone?
Yeah, I would say yes. We still have a role to play here. It's not that you can do like, let's take Tableau. And I use that in class sometimes, and give a problem, some data set to the students and tell them, try to solve it with Tableau. And in the beginning, they are very effective in getting first results. But at some point, they figure out, no, it's not going to work with Tableau. At some point, they have to go dig deeper if it's not a simple problem. Of course, many simple problems you can solve. And for that, I don't think people need us. But if it's a little more complex, if it gets into more detail, the data is more complex, the task is more complex, I have the feeling that very quickly you find out you need to do some more in-depth work. It's not like you can do it in half an hour with Tableau. So the first half hour with Tableau is great. And then you try to do things that are not thought like the Tableau is not made for. And then it's getting very hard and you take the data out, change the data, load it back in and so on and so forth. You do all these tricks to still work with it. But then Tableau is at some point not the right tool to be used. And then you need to develop some technology. And for that, I think we are still the right researchers to do it. We have to probably focus on more interesting problems at some point. Like maybe some of the problems are solved, and that's fine. It's perfectly fine for me if there's a ton of problems that I don't have to deal with because there's still enough left. At this point, there's still so many applications that I could work on where my research is needed that I'm not worried about the few that may be taken away by Tableau and the standard tools.
And I would just say that for me personally, I'm involved in more projects than I've ever been involved with at the same time in my career. I have 14 funded, federally funded projects right now. I'm getting more and more people as I engage in other communities are seeing the role of what we can do and deciding that we're necessary for them to be successful. So as you're doing convergent science, as you're really trying to solve the real world problems, our role becomes critical. We may not be the PI of these, but we get involved and we play a key role for their success.
And my point of view is visual analytics is a process, and a process who starts with data, wrangling the data and gaining insights. And this is not a one-shot. Yeah? And therefore, for this supporting this process view, we still need us as scientists to conceptualize this process view and support the different kind of interactions. And for example, what we didn't achieve and what we promised 20 years ago in visual analytics is that we define a science of interactions. And the science of interaction is not there yet. Yeah? And this supports all the process views.
I would like to ask a follow-up question on the fundings, as I know that all our panelists are very successful to seeking fundings. But as a young professor, as I just joined, do you have some advices for juniors to build out their funding portfolio, and any lessons you have learned from building out the visual analytics portfolio to help us get funding?
So one advice that I have is be willing to get involved with application researchers. Really get involved with them. And sometimes you have to start doing simple things for them. It's not like they come up with the most interesting problem for you to start with. Sometimes they need to be convinced first by doing simple work for them, helping them to understand their data, which you can do with Tableau and other tools, maybe able with very simple means. And I always tell my PhD students, do the first steps, And then you come probably to a more interesting problem later. And establishing that collaboration, depending on the kind of discipline that you work with, may take a couple of years. It's not like done within like a month or two. That may really need to take like a few years, because it's about trust, that they trust that you can help them with their problems. And I had people from some disciplines that told me, oh, that's all simple, I can do it myself. And then I said, okay, perfect. I don't need to work with you because you can do it yourself. Of course, they couldn't do it themselves, but that's depending on like that trust level. And others were really willing to get involved. And as David pointed out, you are often not the PI, the first PI on that like grant, because it's their problem and they have to be in the first line. But you are essential to solve the problem. And we have many of such grants where we are second or third PI, co-PIs, but instrumental to solve the problems. And actually you are often core because you are integrating all the software. You're basically the core point where everything is put together. That we have quite often, like software-wise, we are integrating everything, every component. All the data comes together in our program, and we build the interface for everybody, which of course is part of what visual analytics can do.
And I completely agree. And, use-inspired research, convergent research makes so much sense, working with all these domain people. Besides the fact that it gives you new venues to publish in, and to take, same projects and look at different aspects and publish in two different domains. Oftentimes citations in these other areas are much higher. I mean, the work in working with dietitians gets huge amounts of citations because people cite a lot more in their field when they publish. But I would also say a key component to do that is how you explain what you do and your skills are. If you consider yourself a data scientist and that you will not just solve their visualization problem, but help them turn data into useful and actionable information, which was a key tenet of visual analytics, is the actionable information, they will start to understand what you can do. And learning how to communicate with non-computer scientists is a key skill. You need to invest some time, you need to listen carefully, and you need to learn how to remove the domain-specific jargon that you had. So that's really important. And we just ran a workshop for key people on how to communicate to non-scientists. And this is something that I think everybody who's interested in doing work that's transdisciplinary needs to understand. And it's a skill that is easy to develop, but it just takes some practice.
And I would put another view on these dimensions. We are currently talking about a lot of application domains, and I would see machine learning and artificial intelligence also as an application domain. Yeah? And if you team up with these people, then you can develop new concepts and new theories as well as new impacts. Yeah? And I would strongly support not just writing a grant where you apply deep learning or neural networks as another story, but really try to team up and develop new algorithms, new machine learning. There is subsymbolic AI, there's symbolic AI. You can do a lot of knowledge representation to have better visualizations, better methods. I think you need to think beyond these trendy terms, deep learning, neural networks. There is more out. I'm trained as an artificial intelligence person. I learned everything during my studies, and there is more than now you hear in the media. Huh?
So one question from Slido was, what are examples of solved problems that we don't need to spend any more time working on?
Solved problems, okay. Mm-hmm.
Yes.
I understood soft problems, and I thought soft problems.
No, solved.
My feeling is everything that you can do with Tableau, and Tableau is a great tool for take an Excel file or some database of things, and in many cases it produces very quickly a very nice visualization. And I feel that always, like, if I can do it within like 10 minutes with Tableau, great. That is a big success in my opinion, and I don't need to deal with all these standard charts anymore. For many people in applications, I could point them to it and help them get the first view out, and these are the problems that I think are clearly solved. That's a great commercial tool that works on scale with many of the data sources that 20 years ago we were still dealing with. That were things where we developed some software solutions, but we don't have to do that. That's done on a scale that I couldn't support, of course, as a researcher. There are other things that are done simply by AI. We have now tools, AI tools that solve some of the problems that we have been dealing with. So the quality is in some cases good enough for applications. Like we have been working with linguists on producing summaries of text. That problem is solved. I don't want to work on that anymore. And the linguist didn't solve it, right? That was the AI that did the job. So there are problems that are solved by AI or visual analytics, which I'm glad that we don't have to deal with it anymore.
I'm glad you brought up text analysis, Daniel, and I'm terribly sorry to be late. I had a family emergency that occurred just a little while ago. Everything's fine now. But we used to do a huge amount of work in text analysis and text visualization, and I think that largely has gone by the wayside. There are more mature capabilities now. In addition to kind of statistical viz and the kinds of things we do in Tableau, I also feel that a lot of the geospatial analysis, kind of geospatial viz that we used to do a lot of exploratory research on now, there's some fairly mature capabilities on, and certainly in our laboratory, we don't see a lot of research funding coming in that area either. And even in areas we used to work in sort of scientific visualization, large scale viz of scientific data sets, I think there's enough mature tooling now that we tend not to have a whole lot of visualization research going on there. I look at that even in what the Department of Energy in the US funds, which in their Advanced Scientific Computing Research Organization used to fund massive amounts of scientific viz research, and we all built caves and all sorts of huge large-scale displays, and that funding is almost entirely focused in other areas now, largely because I think the tool sets that we have are kind of mature enough for most of our science partners' use.
So related to that, we have a question from someone on Slido who said, I'm someone who hasn't attended IEEE Viz in roughly 20 years. What are the top 5 advances that stand out to you?
I guess, one simple thing that stands out to me is how 20 years ago, the majority of the use of visualization was as a final process of the whole analytical and discovery side of things. It was not part of an interactive exploration or discovery or decision-making process. And as an example, many years ago when I worked at the Goddard Space Flight Center's visualization studio, the week before AGU, tons of scientists would come with all their data and say, make me an animation, make me images to show there. They didn't come as much throughout the year to say, help me understand what's going on with my data, right? And so now the fact that visualization's used through the entire data processing pipeline and the way science is done is throughout it and allows interaction in the integration of analytical tools into it. You just look at the way that Mapbox has all of these advanced analytical tools inside the library of how do you create geospatial visualizations, right? That sort of is an example of a visual analytics tool that a lot of people might not think about.
Another thing, what I think is also already solved is if you have multidimensional, multivariate data, what do you present how to explore multivariate, multidimensional data? You're using multiple coordinated views. And this was not there years ago. But now, if you look, everybody's using multiple coordinated views. If you want to see different kind of perspectives, you have another view.
I think the other key trend I've observed is just, and it kind of goes back to this point about the relationship between the visualization and visual analyst communities and the data science and AI community is a lot more comfort with visual representations of abstract data. So I see a lot of our material scientists now being very comfortable with visual depictions of SVM representations of embeddings as a result of some computer vision analysis. And so I think I've observed maybe through the last 20 years of visual analytics a lot more comfort level with folks outside of the Viz community using Viz capabilities as more sophisticated Viz capabilities as part of their work. And I think that's partly a function of folks in this community doing a good job of outreach to a lot of those practitioner communities. But I think that level of sophistication that I've observed among our domain science partners has increased pretty dramatically even in the last 5 or 8 years or so.
I think it's also increased in the general public. I mean, in the New York Times, like the Science Times and all of the publications around the world going to more and more advanced ways of showing things. And on their websites, creating interactive tools instead of static tools. And I think actually that's one of the benefits of the use of visualization and interactive analysis from the pandemic is so many people started using interactive visual displays to understand what was going on and how their life was being affected and what was going on in their local community. It just became a natural process. Just like the fact of having mapping programs, right? Google Maps changed the way people start thinking about maps and interacting with maps. If you take map literacy today of the general population versus 30 years ago, there were many people who had no idea how to read a map. Right? Mm-hmm.
I would just build on that, David. The thing that brought the most joy to my heart, I would say, in the last 20 years, was last year. My middle school daughter, 8th grade daughter, took introductory computer science in middle school, and toward the end of the year, one of the projects that everyone in her CS class had to work on was to develop a visualization. And I thought this was pretty remarkable. That I doubt most of us in our first CS classes were taught principles of visualization, let alone in 8th grade. So just the fact that this was sort of part of the normal CS curriculum, and even had students at that level thinking about what are problems that are appropriate to solve visually, and what are principles of visual interaction, and the fact that this was part of now middle school and high school CS curricula was, I think, one of the best advances I could have hoped to see in our community.
And how does the visualization look like?
Not too shabby. I'll bring it up for you. I'm sure she'll be presenting at VAST next year. So
no, I was just curious. I was also thinking maybe we need young people who do our creative stuff.
And I had a similar experience, not quite that good, but I had colleagues send me email from their daughter, 2 colleagues, and she was a machine learning person working for a company that went public, and now she's got her own AI startup. And she said, I just read this cool paper on interactive visualization of ensemble learning. Do you happen to know this guy? He also works at Purdue. And it was the first time someone's child from a different field was looking at one of the papers that one of my students and I did. So that just shows that even 5 years ago, people in machine learning were using the work that was coming out of the visual analytics community.
Maybe I'll use my privilege to jump in for a second then to follow up on something Bill said. Yeah, we listed off some solved challenges, and Bill listed off, GeoViz capabilities, really mature text viz, SciViz capabilities. All these are seeing less funding. So what does this group see as the fundamental unsolved challenges now on the flip side of that?
So I see clearly a new challenge coming up with interfacing with all the big AI models that is not solved we haven't built, like, of course there are some tools out there, but something that really helps and is used on an everyday basis, I don't see yet. There is still plenty of open questions on how to actually do it, and how we can help solving problems that are currently being solved, like understanding LLMs in a way that it helps people in using them, makes them aware of things that are going on in the background. Because the models are too big, too complex, and like just telling them on layer 20 there's something happening doesn't help anybody. And being able to dig through millions of parameters doesn't really billions. Yeah, it really doesn't help. And everything that I see there is good starting points, but I don't see it being used in practice yet. And I'm actually for talks looking myself for visual tools that help explain some things, and I haven't found some that I can really use for that purpose. So there is still a big open question how to interface with AI, and that I would pose as an open question: how much verbal interaction do we want? How much of it should be visual? And I have not a simple answer to that. There could be different means of communicating with these tools, and we should explore a combination probably of all the interaction mechanisms in order to make it really useful. But there are open problems, large open problems that will keep us busy for the next decades.
And I think go ahead, Sylvia.
Okay. I totally support what and echo what Daniel was saying. We need really to open the black box. Yeah, this is one challenge, that to really understand, explain them what's going on, and we could use different modalities. One is visualization, one is verbal one. Also to give the people more trustworthiness, more explainability. This is one thing. Yeah. The other thing is what we didn't really solve is there is so much background knowledge out, yeah, what we need really to integrate in our visual analytics approaches. We need more knowledge assistant solutions. The other point is currently there are so many visualizations out, so many tools out, and analytical methods out, also for machine learning. The people are overwhelmed with the different options. You need some guidance. Yeah? And the other thing is, what I think is still open, is the science of interactions. And the other thing is still open, in my point of view, to having good evaluation strategies to really support that we are really gaining some insights on a qualitative and a quantitative level.
What I was going to say is in the rank, specifically in the trustability and explainability, science-based or domain-based AI solutions, the role of interactive visualization and the role of the human in that, I think still needs to be solved. Is how do you really get that good symbiotic relationship? And as you mentioned, what is good verbally? What is good through visualization? But how do we do that balance, and how do we create that trust? And some of that comes into how do you display, a common problem that's been on the top 10 unsolved problems in visualization ever since I think the list were created, is sort of uncertainty, trust, these concepts that are hard to quantify and hard to represent. And I didn't put sonification in as a modality. I have seen a few papers recently on sonification. That was a popular area 20 years ago in the sci-viz community, and no one really came up with metaphors that people were willing to listen to for hours to understand data. Maybe that's still an unsolved problem, but I think the speech, the text, a lot of things are much easier for people to read than understanding a complex visualization. But there's other cases where visual cognition, as was determined 10 to 15 years ago, there is actually cognitive processing that goes on in the visual system. And the boundary between visual perception and visual cognition from cognitive scientists that I talk to constantly changes by what they understand. Once they understand it, they call it visual perception. When they still don't understand exactly what's going on, it's visual cognition. But there still is that role where it can be really useful. But there are a lot of cases where how do you bring human domain knowledge in to provide context to provide additional information into the automated learning systems, I think is really a case where interactive visual interfaces plays a key role.
And I think what is, sorry, just to add something, what I forgot. I think this human in the loop, or the human is the loop, is very, very important. And there was a concept in AI many years ago, which was called mixed initiative, where you have the system taking the initiative or the human taking the initiative. And this mixed initiative approach need to be re-established, particular for the visual analytics community, because there are parts where the human is better, there are parts where the system is better, and then you can really have this new ways of mixed initiative visualization.
Yeah, I would certainly just echo that, one of the, I think the lack of progress we've made in kind of integrating the cognitive science community and psychology communities into our work has surprised me. It turns out it's apparently harder than I thought it was going to be. Maybe just the impedance mismatch from a technical community perspective. But I don't feel that we've made nearly as much progress on that front as we should have, such that 20 years later, I feel like I'm still having some of the same conversations in our science labs about how do you do this process of discovery, and how do we document it, and how do you support it, and just for whatever reason we I don't know if it's a language problem, a domain alignment problem, but we've not addressed that well, and it might be time for a rethinking. Ironically, and I think it goes back to the topic of trust and transparency in AI as well. Although I think that in large part a lot of the historical work that we and others did in text visualization might be a solved problem. In the last just 6 months or so, I've had a lot of people starting to come to me asking if we have text visualization tools. And I'm like, well, we used to, but why are you asking? And it's like, well, we have some internal generative AI tools that we use, AI research assistants. Like, well, these things are great, but they're generating way too much text for me to read. Are the things I can use to kind of summarize and visually depict patterns in that text. So it feels like, again, we're kind of coming back around 20 years later now, generating text content through a lot of these generative tools, and now needing some better ways of summarizing and finding patterns in it visually. So I think there's an opportunity to maybe reassess some of the historical text viz work that we did in the sort of generative era, and think about how we even build visual interfaces into I've got the ChatGPT Enterprise sitting on my desktop that we use pretty extensively at the laboratory, but I also sort of find that interface ultimately limiting for asking some complex questions or understanding patterns in complex data. So I think there is some possibility to think about how we build visual depictions into what has started now as kind of natural language based interfaces.
And I would just sort of echo, Brian Fisher and I have had long discussions on why weren't we as successful in reaching the cognitive science community. And I think it's because of not understanding the taxonomy, all the different groups and what they do for research and what's important for them, and taking the time to understand some of their problems, because there's sort of clinical psychology, there's experimental cognitive psychology, there's more theoretical, and really getting into that right subdomain and understanding where we fit in. And you're right, a lot of times it's, as I mentioned earlier, it's a communication problem, right? How do we really understand their problems, and do we take the time to really have enough discussions with them? And there's going to be a Dagstuhl next year talking about how cognitive science and psychology come together with visualization. And maybe it will be as successful as some of the more recent ones, which really are trying to get sort of as many people from the other domain as there are computer scientists that show up at Dagstuhl. So you really get good collaboration over 4 or 5 days, and that can start it. But it's finding the people to make sure that the collaboration works.
So after 20 years, is the era of fundamental visual analytics over? Can we still do fundamental visual analytics research, or do we have to piggyback on solving application problems and can do our research within that application problem or domain, and then can transfer from there?
I think there's still fundamental research. I think some of the problems we've been talking about, we would consider fundamental visual analytics problems. It depends how you define it. But I think and the other thing, the best thing about when you work with these applications, you find things that people haven't solved subproblems of, right? And it leads to new innovation. I mean, if you look at Pasteur's quadrant, use-inspired research can really lead, and application-driven research. There's been a lot of work over the past 7 or 8 years that have shown that use-inspired or application-driven research actually leads to an increase in the rate of innovation within science. And I think it does as well within our field. I know with all of my PhD students that when we're working a lot with end users, with police and emergency responders, et cetera, the whole goal of the advisor, I thought, was to find out what is the fundamental visual analytics research there that will help them get their PhD. And I think there still are a lot of cases as you get into these areas that there's fundamental work that you discover as part of the process.
Yeah, I would echo that. The science of analytical reasoning that was pretty high on the agenda to the beginning, I don't think we have that yet. So, look into the Illuminating the Past book. That was one of the topics, core topics, fundamental. I don't see it yet. So there is still some of these problems left, even though we have solved many of the detailed problems, like application problems. We have made quite some progress, but on the fundamental side, I see still some work to be done.
And I also think on the fundamental side, for example, again, it was also a topic in the Illuminating of the Past. The research agenda for visual analytics was the science of interaction. Huh? We didn't solve this at all. Or
I think as I maybe mentioned a bit yesterday, there's I would say a leadership gap, a research leadership gap in really kind of asserting the role or roles for humans in the design and control of autonomous systems. There are some subfields of folks who are working on that, but I think that's also an area where the visual analyst community can sort of step up and lead. I think we don't have good practices and principles, and it touches, I think, on everything that the visual analytics community has worked on in the past, starting with the science of analytical reasoning. But I think I sort of see that white space as one that's kind of either there for folks in the viz community to kind of step up and help own or drive. Or it's going to be determined sort of for us by folks who come out of different worlds, come out of the process control world or the autonomy engineering world or the robotics world, and I'm not sure that's the right place for that thinking to happen. So I'd certainly like to see more of our viz folks kind of guiding that conversation and kind of maybe asserting where that role of humans in these complex autonomous workflows is, and ultimately human interactivity is going to involve some degree of visual interaction, which then sort of makes the role for viz and VA central in an ongoing way.
And I would just, say you were referring back to Illuminating the Past. There was a special issue that Bill and I were talking about a couple of weeks ago of the journal Information Visualization. That was 5 years later, what has been done and what was still unsolved. And, sort of relating to this, in reviewing the papers, I think a lot has been done, but an area that I think is still, I like the statement in the opening that was saying, our visual analytics sciences will enable prospective and proactive thinking well beyond today's confirmatory and exploratory methods. And I think the prospective and proactive side of that sort of gets into that human-computer teaming problem. And it's something that people are still very interested in. And I know, talking to people who are leading government agencies, when you talk about human-computer teaming and collaboration, it draws their interest immediately because it's a problem that so many fields and so many areas are facing. And the fact that you're talking about creating an interface to understand how to do that becomes something tangible and helps someone get sort of a frame of reference to understand the best way to do that. And so I think as framers for solutions for that, we can play a critical role.
And that problem will not go away.
But I don't think it should just be us, right? Our community needs to grow to get in the cognitive scientists, to get the people in decision science, to get the, the behavioral economists who've really studied issues on cognitive bias and bounded rationality and all of these traits that need to flow into this. So we do need to grow the subdomains that we interact, the domains that we interact with. I think.
And we also, so one thing is cognitive science. Yeah? The other thing is also artificial intelligence and machine learning. Yeah? This is also a quite complex stuff. Yeah? And we need to team up with the people. Yeah? And if they want to develop new algorithms or new concepts, they can use visualization for opening the black box and providing explainability and trustworthiness. I think it's a collaborative approach. And I think this was also one aim of illuminating the path, that visual analytics is an interdisciplinary field. It's not a monolithical field. Yeah? And therefore, we need to really team up with the different disciplines. One are application domains, and the other one are within in computer science. Yeah? We also have to team up a little bit with HCI. Yeah? But currently, we are pushed to team up with artificial intelligence and machine learning. And cognitive science, of course. But in my head, this is always part of visual analytics. But I totally agree with what David was saying. We didn't succeed in this circumstances. We always had it on our list, but we didn't succeed. Brian Fisher is still not here.
All right, we needed Daniel Kimes was great in reaching out to the KDD and that community, given his background, and he was such a great proponent in getting them engaged. We weren't as successful. We needed Daniel Kime from cognitive science, right?
But I think also we need, one is cognitive science, but we also need to bridge to the machine learning and artificial intelligence community, because otherwise, I mean, look what they are producing for visualizations. Yeah,
right.
I mean, my stomach is really hurting if I.
There are some great people there, like Polo Chow, and there's Hendrik Strobelt, etc. There's people who work in both. There's a handful, and those are just two examples. But we do need to grow that more, right?
Yeah.
And we need to make it where they feel as comfortable. In one question that has come up over the years through Viz is, are we a welcoming environment to people from these other fields? And can they, will they come to our conference? Will they find it useful, right? When Viz started, the first year that I went to Viz, there were people from NASA Goddard, there were scientists from NASA Goddard who were going to the Viz conference because they could present their work and it was accepted there and they could understand a lot of the program. And maybe it's the growth of a field, right? As you get more and more and you get more technical and more focused, you tend to push out those people. And maybe it's something that we should really think about is how can we be an AGU-like environment where you get people from dozens of disciplines all coming together and picking what's interests them across a large program like that.
Yeah, and the problem that we have in AI is that these communities are so big. Like if you see how many submissions NIPS gets every year, ICLR and all the other machine learning conferences, visualization is a small field. Visual analytics is a very small field. Like how many papers do we have at this? They publish 2,000 papers at NIPS, publish, and it's highly selective. And it's like you can't even submit there unless you also provide reviewer. So if you're not willing to review, your paper is desk rejected. So it's like, because they can't handle the flood of reviewing that they are into. So it's like, I fully agree, we have to team up, but it's not by no means trivial because there are so many niches, so many areas and like you can't even follow up on all of it. So that means even more we need to team up. Yeah, it's pretty clear that you are lost if you try to read all the NIPS papers. There's no way.
Yeah, I definitely see that. I agree, Daniel. And even just, a lot of our publication activity typically is trying to, our Viz researchers partnering with folks in our AI research groups to then join forces for things like submissions to NeurIPS and others. I think the other area that we start to think about exploring, and it kind of goes back to the science of analytical reasoning, and it's just sort of this inevitable recognition that although we're having a lot of fun with natural language-based interfaces to LLMs, you sort of realize that from a productivity perspective, you sort of reach an asymptote pretty quickly. Like it turns out that not every problem in science is solved through a linear sort of chat-based interface with underlying model. And that's a really slow and annoying way sometimes to discover data. And then we go think about, well, hey, why do I have to do this linearly? Is there some sort of tool that could show me all of the data and patterns and relations at once, and I can do a sort of synthetic analysis rather than sort of prompt-based way of probing a system? It's like, oh yeah, it turns out that's what we do in visualization. So I think we're also starting to see, like in our science lab, someone asked a question in chat, I think, about where LLMs can help scientists do our jobs better, and we use them extensively for things like synthesizing background research. But then you also start to discover like it becomes a very inefficient way of exploring scientific data, and very quickly the shine wears off, and you're back to kind of old-fashioned visualization to help you understand the patterns of data that you've collected. So I think again, we can lead in helping to sort of architect what are the right workflows to integrate sort of chat-based interfaces with traditional multidimensional visualization. I think we're seeing more recognition that in some cases the novelty is sort of wearing off the kinds of LLM-based interfaces that we've started to deploy.
What I want to add to Daniel's comment here, that we should go to machine learning conferences and review for them and so on. We should make it the other way around as well. Yeah, we should invite people to come to our conferences. If you look at our papers, yeah, look at the best papers. What were the best papers about? MLMs and so on. Yeah, we could do it in both directions. Yeah. And we should start simple. I mean, Bill was mentioning they are collaborating in their lab. Yeah? We also started at the TU Wien to collaborate with the AI people. We had now a cluster of excellence with dealing with bilateral AI, and I'm also involved to do the visualization there. Yeah? But my principle is really the teaming up. Yeah? And we have to go in both community, and don't be shy. Yeah? I mean, shy is not the right word, sorry. But we have to be active. Yeah?
So maybe for the last 15 minutes, our look into the future question, what advice do you have for next generation researchers? What can they do in visual analytics?
My point of view, my advice for the next generation would be to see visual analytics really as this interdisciplinary, transdisciplinary approach, where you need to team up with the different people, try to do this, and really focusing more on this mixed initiative, how I call it, or the human in the loop approach, yeah, and try to do this from the theoretical and practical perspective. And the process-oriented, because we are not producing beautiful pictures. Yeah?
I would still advise them to select an interesting pressing problem. For example, manipulation by LLMs, like biases in LLMs, whatever. Like there's plenty of things that are happening. They are all determined by companies, or mostly at this point. It would be really societal relevance, of high societal relevance, to open that, make it public, make it known to people, being able to explore that. It's incredibly hard. It's a really interesting problem, but this is just one example. There are many out of these examples. Pressing problem, and then see how to solve it. And maybe AI can do half of the job, or 3/4 of the job. You will find out in most cases the human needs to be involved in for complex problems. And then you have a very good problem to start working on, and you're highly motivated because you really want to get this solved. And that at least helped me in my career a lot, that I was really, really convinced that what I'm doing is relevant and needed and should be done. And that kind of makes a big difference instead of just selecting a problem for academic reasons.
And I completely agree. There are so many important problems that hopefully have value to you so that you can see the impact that you're having and get more out of doing it than just publishing a paper. I mean, examples of things, but make sure you reach out to other people, because bringing other domain science into what you're doing and the visual interface will become natural in it is so important. Looking at misinformation, this is a huge problem that's going on right now that we've been working on with some automated techniques, human in the loop techniques, but we're also working with communication people on understanding, what are the ways that people try to influence people. And as you bring more and more of the grounded theory from different disciplines into what you're doing, you'll be able to find unique ways to do it. So there's some problems. You just look at the grand challenges of the world, right? Stability of society, misinformation comes in. You look at sustainability, you can look at agriculture, you can look at green energy, you can look at greenhouse gases and methane. There's all these problems. You can look at disease spread and the whole One Health approach. I mean, there's so many different things that you can look at that you can make a career on, but you can easily find what are the interesting ways that you need to transform the data. You need to integrate visualization and come up with new ways of representing the visualization and put the human in the loop to the problem. And so you really, I think of what we do in visual analytics as sort of a systems of systems or systems engineering approach, and not a fundamental, pure processing approach to doing things. But having skills across those different disciplines can also help you. Right? And by the fact that you pick up these things, it creates a unique capability for you to get grants that other people don't get. It gives you more diversity while you still have your depth when you're applying for jobs. I had a job interview where I was using Tinker Toys to explain what I was doing in my PhD dissertation. Most people really appreciated that, except one department head who said, "Oh, I didn't realize we were in kindergarten," when I came in to give it. But, at that point, computer graphics was considered an application and not to computer science. But the fact that I knew databases, I knew data science, I knew numerical analysis, then they felt I was a real scientist, right? So you need to make sure that you have a well-rounded aspect, but it does allow you to broaden where you publish, broaden your collaborators, and get more a reward than just your next publication out of what you do.
I'd underscore that the value in having that domain affinity, and there's some pros and some cons definitely to building that into your career. But I certainly see where we've been most successful in visual analytics research and in tool development. It's when the research team, the people working on that capability have built a really strong alignment with the domain science application area. They really live and breathe it. There are even cases, and I look kind of at our history of kind of just workforce development and alignment inside the laboratory, where we've over time kind of spun off teams. We had a team actually in a group that I used to lead. It was more of a data science oriented team, a group, but a team of folks who were really doing some excellent work in analytics and viz for biology. And eventually they went to kind of work inside our biology division. I think that's a good thing. And so, I also try to balance, the value of doing basic research, solving generalizable problems with not being a dilettante, as it were. And I say that with the mirror kind of holding up to myself. And I see a lot of sort of, dilettantish behavior sometimes in my own research interest, but really having impact often means getting aligned very closely inside a domain science team. So I think, finding those domain problems that really inspire you and building out a portion of your career that really allows you to deeply understand and appreciate those problems is critical, because then also allows you to have impact. And as David said, I think Dave and I were talking about this at one point, I always liked it because I got 2 papers instead of 1, because I got 1 in the CS literature and 1 in whatever domain science we were also publishing in. So there are some practical considerations as well.
So we got another question from Slido, actually two
Could
questions.
I make one final
Oh,
comment
sure.
before we get that last thing? You know, I always suggest that you really look at how the successful careers of people in the field have gone. Something that inspired me many times was through collaborations with Pat Hanrahan and his approach of going and looking at how people have traditionally solved the problem. He gave a great talk at InfoViz a long time ago that was entitled How to Draw a Tree, because so many sciences, you know, the structure of the data is tree-based. And he went and dug up all these classic biological problems and really looked across a variety of disciplines over the centuries, how have people represented that? And looking to a field of the way that they solve a problem independently from a computer scientist, and then figuring out where the computer science and where it can advance what was been done before can really be insightful. And sorry, Wolfgang.
No worries. So yeah, the question from Slido was going to ask, how would you think about the gap between analysis and communication / storytelling?
But I guess that's maybe another area of a gap. If I go back to the original illuminating the path agenda, there was this chapter on production and presentation dissemination. Again, in hindsight, it had this sort of very sort of intelligence analysis flavor to it, which was very limiting. I think it should have maybe reflected more just on kind of how we communicate the results of research generally. That's probably another area where we haven't made a ton of progress. There's certainly tools. Daniel mentioned Tableau, and certainly I use Tableau and can use it to kind of help structure a story. And some of that tooling is very helpful. I don't know that we've necessarily improved a whole lot in terms of our ability to help researchers or analysts communicate the results of their work. In some ways, I sort of see the use of LLMs creating a sort of step back. Well, now I'm just sort of creating the same sort of text-based reports that I always used to do, now just with a little bit of a writing aid, but still missing all of the ability to integrate visual representations into that work. So that's another concern I have, is sort of where the rise of LLM kind of take a lot of the oxygen out of the conversation around kind of how you communicate the results of a research activity, a finding. Because we've kind of reverted now to a set of tools that kind of put us back into this sort of narrative construction mode and remove the ability to have those sort of rich visual analytic products that I think we originally envisioned in the research agenda.
For me, this is a natural gap between analysis or exploration and storytelling. Before, you have to understand what's going on, what is in the data, what hypotheses are there, what insights. And if you have found something, you can tell a story. But first, I need really to get these insights out, and then I can have a storytelling approach.
And I think in that sort of follow-up 5 years after illuminating the path, there was some talk about automated tools and enhanced documents that had the visualization and the analysis embedded in them. And I don't know that a good theory, an automated way to do that has been generated. Palantir is a hugely successful tool and was a very successful company. And everyone that I talked to who used it gave two reasons they liked it. One was credential management, to allow you to get access to all the varied data sets that you had permission to get access to. But the other one was to document and tell the story of what you developed. But again, that was tailored towards the traditional government analysis and not the scientific discovery. So really understanding how to do that is something that I still do think. And when you look back at what was done in 2009, that was only baby steps to doing this. So I think it still is a gap today, but I think it's something that being able to create that interactive process or that self-documenting as you go through the discovery, how do you determine what artifacts to save to present your reasoning, are interesting challenges. That there's been a lot of work in our community on storytelling, and I think that probably a lot of people in visual analytics haven't been as actively engaged in that subset of our community to take full advantage of all the great advances.
So maybe as a follow-up, also a question from Slido, how would you explain the scarcity of data visualization related jobs outside of academia? Are we living in an ivory tower?
I don't think that is true. I see many years, decades of producing students that have been doing research, their bachelor, masters, and PhDs in visual analytics. They all find easy jobs. There is a big market out. Maybe they are not developing the next cool visualization, but they are applying what they have learned in solving problems, in interfacing human interfaces with machine learning, with analytical systems. And there's plenty of need out there in industry. So I don't see that really being the case that there are no jobs. Maybe not for the next fancy visualization. Yeah, I don't think companies are on that edge of inventing the new visual metaphor, the next new one. And so I agree on that side. It's not only visual jobs, but doing what we do best, solving real world problems with human and machines together. That is certainly what is needed and will be needed in the future.
And what good side effect I observed during the pandemic or during COVID time is that the people were really eager to visualize their selected data, and they really learned the added value of it. Yeah? Again, as Daniel phrased it, not new fancy visualization, but to communicate the danger, to communicate the situation to different kind of persons is a need.
And I recently gave a talk at an Infometrics conference, a completely different community, all on information theory and understanding information communication. And in guidance for it, Min Chen said, when I go outside of our community, I describe what I do as data science. I don't describe it as visualization, because people don't understand everything that's involved. They have a different view of what the word visualization or visual analytics means than what we do. And so I think it's how you present yourself and what jobs you look for, because it all rolls together. But most people don't necessarily bring to the forefront the role of the visual component. And your skill set is much bigger than that, right? You're really learning how to communicate information, how to turn data into information that's usable. And so visual analytics is sort of a community-defined term that isn't as widely known in a lot of areas. So that's why it could be the way you just describe yourself.
Okay, we are almost at the end. Maybe just one of you can answer, or very quickly, will we have another panel, visual analytics panel in 20 years, and will we still call it visual analytics?
I would say definitely yes. I don't think we need a new branding of the term. We need to contextualize it much better, because we need 20 years that the people understand what visual analytics is, and now we need 20 years to do a foundation and practical impact.
Yeah, I'd agree with that. I mean, if you look at sort of, the broader challenge of data-driven discovery that we all wrestle with, requires a spectrum of skills from folks who are just, fascinated by and advanced kind of a lot of, underlying architectures, hardware design, data management, through to this huge spectrum of things, and folks who think about kind of the human dimension of that. And that spectrum isn't changing. The individual roles, the capabilities along that spectrum evolve over time. But there's not a future where you don't need everything across that spectrum. So I sort of see visual analytics as largely being folks who are kind of on the more human-oriented side of that spectrum, but still have skills through a lot of the same underlying ML and data management capabilities. So I don't see any of that changing.
I fully agree. Yes, we will have another panel 20 years from now. I'm not sure that it's still called visual analytics, but who cares if we do the same thing? Human interaction with analytics, AI, whatever. And that will be needed, as Bill pointed out. So yes, the topic will remain relevant. Whether we call it visual analytics, I personally don't care. This is one term out of many but of course, changing terms is not a good idea. So I would leave it there.
And I agree. I think the topic and what we're talking about, the techniques, the body of knowledge will remain. Terminology is sort of irrelevant. And I know we're wrapping up, so I would just like to say I've had a great time discussing all of this, and hopefully all of you who have posed questions and have been involved have as well.
Yes,
Thank
thank you to you guys. It was a really nice and interesting discussion. I had a lot of fun listening to you. I hope our audience liked it too. Give some clapping hands on Discord. And thank you again, guys.
Bye.
Thank you. Bye-bye. It was great talking to you.
Thank you.
Thank you. What fun.